Yeah, well, since the space age started in the 1950s, we have launched thousands of rockets and sent even more satellites into orbit. Many are still there, of which many are not working anymore. Meanwhile, there are over 500,000 of pieces of debris orbiting our planet. And this rising number of space junk increases the danger to all space vehicles, the International Space Station, and other spacecrafts with humans on board. And Emmanuelle David is the executive manager of the EPFL Space Center, and she will present the initiative, main research streams, and key technologies enabling sustainable space logistics. The stage is yours.
Thank you. Thank you for the nice introduction. Hello, everyone. So as I mentioned, Emmanuelle David, I'm executive manager at EPFL Space Center. Our goal is to mentor students there that are studying the minor in space technologies, but also push and find further space applications, the research that is performed at EPFL. So to start, I would like to know, does anyone know who is this person there? No? So maybe you heard a few weeks back, there was this first like whole civilian flight from SpaceX. And this is Dr. San Proctor. She's so a scientist, but she's also does a lot of STEM outreach. And so you can see her watching out of the Dragon Crew capsule. I think this is a great image because it gives also hope that maybe one of you also will be at her spot, like in the next years, who knows? Maybe you already have like billionaires friends and they will pay ticket. I was making the joke to one of my friends, I think I don't have the good friends, but actually they were not chosen because they are friends of the billionaire who sponsored the flight, but also because of what they do. And she's great also in doing outreach, and that's also why she was chosen. I also chose this picture because while I was reading the news about this flight, I could see also a lot of criticism about like, wow, those billionaires, they are like spending money and then consuming a lot of energy, and like how many flights it is from like Paris to Los Angeles and how not sustainable those activities are. And this is true, and this is a fact, and that happens also with technology, with new technologies, there are new challenges. And nowadays, I think for all of us, the big challenge is like to keep pushing the boundaries while staying sustainable, because we are learning from our mistakes and we don't want to continue the way we're doing things. But before going forward, I would like just to step back or a bit higher, like go far, far away in space, and then you can look what is the space economy today, because this is human space flight, as I showed in the picture, but this can be also here satellite communication, and here you see IoT, so this links to the talk you had before, all this 5G stuff, they go through satellites, so this is very important to have this space-based infrastructure. GPS, who can survive without Google Map? No, no one. So yeah, global navigation. Yeah, Tanya mentioned the space station, but also the suborbital flights. And now also there is a new economy raising up, is that as we have more and more satellites, you have also on-orbit servicing coming up, refueling of satellites, repairing satellites in space, but also space debris removal. And maybe also you've heard in the last years, here we are also starting, a lot more people are going back to the moon. So it means that so far you had the Apollo missions, it was all from NASA, but now you also have private actors going there and they want to do mining on the moon. And also then the second step will be to do the same things also on Mars. So there is a space economy that is building up. It's like billions of dollars, and it's going to be way much more in the next 10, 20 years. So also, what we also need to know is that there is this space debris situation. So you have 36,000 objects, more than 36,000 objects, more than 10 centimeters. So it's like this size. So you have also to think it's all the satellites. But then you have also like smaller objects, like 1 million greater than 1 centimeter. So even 1 centimeter is not that big. But what I want also to make you aware of is that in space, the objects, they go very, very fast. So it means in low Earth orbit, they go 7 kilometers per second. So if you have an impact, you see here on the image, no, it's not that, it's this one. You see here, like this small ball, like make the impact. it has huge damages. And so this is also important to picture. And even if also the density is not so high in space and you have all those objects that are in this huge like space, the probability that they can cross is also much higher because they rotate very fast around the Earth. So also another figure which is important is you can see there on this picture, on this graph that, so this is the objects in orbit today, and those are unused objects. And the red are the ones that are currently active and useful. So this is kind of impressive. So as we know, yeah, there's a lot of space junks because we've been sending stuff in space, just like as if you would like go on the highway, drive, you know, from Zurich to Bern, but then you leave your car on the highway when you arrived. So that's not very sustainable. And as also I mentioned, you have also an expansion of space activities. You have new actors like SpaceX. They are sending thousands of satellites, doing like much more flights. And it means the trend is going up and it's exponential. So I don't want to scare you, but if we are not careful, it can be tragic. But it's okay, because there are some solutions and a lot of people are working on it, and we are doing this. So you have some hard solution, like I would say hard in terms of like this is technology that are being built. And there is this one startup that spun out of EPFL a few years back called Clear Space, and they've been awarded 2 years ago a contract by the European Space Agency to go remove the first piece of debris, the Vespa, which is an upper stage from a rocket. And they will go and they will pick it up and then remove it back. Of course, this is a demonstration mission. They should do it by 2025. But the goal is not to each time to send one satellite to get to pick up one piece of debris, but after they will go and remove several pieces of debris. Then if we go one step below, thinking about the mission, there are also technologies that needs to be developed. And these are also technologies that are currently being developed within EPFL labs. One example is the relative navigation using computer vision, meaning that you have the chaser that will go and pick up the target. And the technology that they are being developing is that you don't know how is the target behaving, if it's tumbling and how much it's rotating. And it's that the chaser should be able to understand while taking pictures of the target, to understand what is the attitude, so then it can choose the best way to go around and then to make the capture. And then also how the capture should be performed, and everything has to be automated, because you can imagine that you don't have a pilot in those little spacecraft that will go to take those debris. Another example here is here we call also design for demise, meaning that at the end of the mission, the satellites come back to perform a direct re-entry on Earth so that it should burn in the atmosphere, but it should break up because you don't want anything then to end up on the Earth's surface and then maybe to hurt someone. So far, no one has been hurt so far from a space object re-entering the space. I think one day there's been a cow that's been touched in Australia, but that's it. So as we know that maybe there's going to be more and more objects re-entering, we need to ensure that nothing reaches the Earth's surface. And here, I think this is another example, and this is pretty cool also, is like for moon exploration application, the work they are doing, they are studying, okay, how can we use the lunar regolith, so basically the lunar dust, to do 3D printing, and what are the properties of those materials. So those are kind of technologies also that are being developed, and that also requires a lot of kind of knowledge, which are not only like space related. So you hear AI, robotics, materials, 3D printing, that maybe, yeah, a lot of you guys are working on. And then there are also what we call the soft solution to space debris. So it's more regarding guidelines and regulation and how to incentivize positive behaviors of space actors. So nowadays there are, for example, one treaty, international treaty, which is from the 70s. And then you have a few guidelines, but nothing like really binding. Because the big challenge in space is that, well, space belongs to everyone, and then it should be, you should find like agreements at an international level. And this is very complicated. I think you already know, like at Swiss level, it's complicated with like few cantons. So imagine with all the countries. So So that's why this is very challenging. And for example, 2 years ago, after almost 10 years of negotiation at the UN, they finally came up with a definition of what is space sustainability. And you can see already there, the definition is kind of a long definition, and it's defined as the long-term sustainability of outer space activities is defined as the ability to maintain the conduct of space activities indefinitely into the future. So we need to be able to continue to do space activities, not just like say, okay, now we stop and we don't go up there, because this will never happen, in a manner that realize the objective of equitable access to the benefit of exploration and use of out of space for peaceful purposes. So equitable access, it means that everyone should access. It's not only the actors that have been already there, like the US, the Russian, or the Europeans, but also all the other emerging countries that also needs to have their space-based infrastructure. And of course, for peaceful purposes, in order to meet the needs of the present generation, so our generation, while preserving also the outer space environment for future generation. That is why our mission also that we have at EPFL is to promote sustainable behavior of space actors by issuing a recognized rating, meaning that we are creating an incentive to design missions that are compatible with sustainable operation, and to also operate mission considering also the potential harm to the orbital environment. And this is through a project we are working on, the Space Sustainability Rating. So we've been selected earlier this year in 2021 by the consortium led by with the World Economic Forum, the University, the UT Texas at Austin, MIT, and also the European Space Agency Space Debris Office. And they've been designing space sustainability rating the last 2 years. And at EPFL now we're also taking over this rating in order to operate it and then to offer it to space operators, so they can also measure the sustainability of their mission, but also then also promote and advertise also about, like, not advertise, but talk about more how sustainable their mission are. But also it means for us, the goal is to help also space operators to be more sustainable in the long term. So yeah, I would like to thank you all, and I hope that with this talk you can picture yourself also, maybe one day you'll be one of these person there on the moon doing some activities there. Thank you.
Thank you very much, Emmanuelle. Yeah, it's always crazy to see how much junk there is up there. Can you just quickly remind us what you've studied?
Yeah, so my background is in mechanical engineering with a specialization in aerospace engineering that I studied both in France and in Germany.
Okay, and is that something that one needs to study if one wants to go into this area?
No, not at all. So basically, it's also what we're trying to do at EPFL is that, as I mentioned, there are a lot of technologies that are needed. So we talked about IoT, but also computer vision, AI, material sciences, so data science. So I think all competencies needs to be are useful, and that's also the work we do with the different labs at EPFL, is that they work on a lot of different other thematics also in any areas, and to bring in also this knowledge to the space field.
So foster interdisciplinarity.
Exactly.
And what made you, what fascinated you about, like, did you always know that you wanted to work in the space sector?
Yeah, so basically when I was a child, I remember seeing the movie Apollo 13, and at the beginning I was like, yeah, well, I'd like to be an astronaut. Sounds really cool, but in the middle of the movie I saw, it seems kind of dangerous, and I'm not sure.
I'd rather stay on Earth.
Yeah, then I thought, well, the guys that are on Earth on mission control, this seems kind of cool, and maybe I'm gonna be one of this person, and that's also why I wanted to work more on the space hardware. Yeah.
Great.
Thank you.
Emmanuelle, thank you very much.
Thank you.
A round of applause.